Hello, my name is Abdul Shakur, a student at the University of Wollongong. Today's presentation covers my research topic, railway track inspection using autonomous aerial drones. This work explores how technology can make railway inspections safer, faster, and more reliable. Abstract. Railway safety relies on regular inspections, but traditional manual methods can be slow, risky, and expensive. Drones equipped with sensors and artificial intelligence offer a modern solution. This research investigates how autonomous drones can effectively detect track faults and deliver real-time inspection data, with the goal of improving safety and reducing operational delays for railway networks. Declaration: I declare that the work in this thesis, titled Railway Track Inspection Using Autonomous Aerial Drones, has been carried out by me as a part of this method subject. The information derived from the literature has been duly acknowledged in the text and a list of reference provided. No part of this thesis is previously presented or for another degree of diploma at this or any institution. This is my table of content covering abstract, declaration, list of abbreviation and symbols, introduction, literature review, and all, and up to research design. And I have also added the appendix or the literature planner at the end. These are all the list of abbreviations and symbols. UAV stands for unmanned aerial vehicle, and the IoT stands for Internet of Things, ML, machine learning. These are the most used abbreviations in this research. As mentioned earlier, introduction. Keeping railways in good working order is absolutely essential for countries that rely on trains to move people and goods. Recently, there has been increasing interest in finding better and more efficient ways to carry out these inspections, especially as rail networks expand and the demand for safer, less disruptive monitoring continues to grow. This project is motivated by all these developments as well as the gaps and often questions that remain. Therefore, based on the existing gaps and limitations, the research paper explores the research question: can autonomous drones, when equipped with live sensors and advanced artificial intelligence, reliably spot, pinpoint, and report track defects even under difficult conditions such as in tunnels, at night time, or in severe weather? So, railway staff can act before an incident occurs. Literature review. Uh, I've added, I've combined all the literature reviews. I've used a mind map for this. I will like to focus on the critics. Despite these advantages, several challenges remain. Drones often struggle in poor weather and limited light, which affects image quality and flight safety. Battery life and range are still limited, making it hard to cover very long rail lines. Integrating these systems with current railway operations can be complex and costly. Data privacy, security, and the need for ongoing human oversight are also major concerns. Finally, while every test are promising, there is still a need for more real-life world trials, especially across different climates and railway systems. Addressing research question, railway infrastructure depends on consistent and thorough inspection, forming the backbone of safe transport operations. This study asked whether autonomous aerial drones paired with sophisticated image analysis can accurately identify and report defects that conventional inspection crews may miss, especially in situations where conditions make manual work harder. Design overview. The engineering research design in this study focused on a practical step by step solution. Autonomous drones with advanced sensors were programmed to scan railways, sending live data wirelessly to a central system. AI algorithms analyze the data to quickly spot cracks, shifts, or damage, with alerts sent to maintenance teams. Both digital simulations and field testing were used. Comparing results with traditional inspections, methods to measure improvements in accuracy, speed, and safety. The system was designed for easy scaling across different rail networks and allowed human experts to review and confirm alerts for best results. Conclusion: to conclude, autonomous drones supported by artificial intelligence show strong potential for transforming railway inspections. These technologies can help spot problems earlier, make inspections safer, and reduce costs. However, success depends on overcoming technical, regulatory, and environmental hurdles. Continued research and wider testing are needed before widespread adoption becomes possible. That concludes my presentation. Thank you.